All right, let's jump right in. Today, we're going to crack open a technique that sounds super complicated, but trust me, it's one of the easiest and most powerful tools you'll ever get your hands on. It's called dimensional analysis, and it's basically the secret weapon for any problem that throws a bunch of different units at you.
You know the feeling, right? You've got this awesome recipe, but it's in grams, and your kitchen scale is all about ounces. Or maybe you're on a road trip, you cross a border, and suddenly everything's in kilometers and liters, and you have no idea what your gas mileage is in miles per gallon. It's just frustrating, right?
Well, what if I told you there's one surprisingly simple secret to solving all of these puzzles? A method that, once you get it, honestly, it's gonna feel like you have a new superpower.
So here's the game plan. First, we'll talk about the universal language of units. Then we'll get to the real secret, canceling units. After that, we'll build our toolkit of conversion factors, learn how to chain them together for some real power. Look at the one big exception. Yep, it's temperature. And then, finally, we'll unleash your new superpower. All right, Section 1, the universal language of units. This is all about understanding the hidden logic behind our measurements. So, what exactly is dimensional analysis? Well, it boils down to one simple, really powerful idea, and it's this. Units, meters, seconds, grams, gallons, they aren't just labels we stick on things. They act exactly like numbers. You can multiply them, you can divide them, and, this is the key, you can cancel them out. This one idea is the foundation for everything we're about to do.
And that brings us right to the heart of it. Section 2, the secret, canceling units. This is the aha moment, the part where it all clicks.
Okay, let's make this real with a quick example. Picture a sprinter running 100 meters in 10 seconds flat. So to get their speed, you don't just divide the numbers, you have to divide the units too. So 100 divided by 10, that's 10. And meters divided by seconds, that gives us meters per second. Put them together, and their speed is 10 meters per second. And boom, just like that, you've done dimensional analysis. Okay, so we know units act like numbers. Now let's get our toolkit ready. And the best part is, you really only need one tool. It's called a conversion factor. I like to think of them as these little keys that can unlock any conversion. A conversion factor is really just a fraction that equals 1. That's it. For instance, we all know that 1 inch is the same thing as 2.54 centimeters. So if you write a fraction with 1 inch on top and 2.54 centimeters on the bottom, you've just written the number 1 in a really clever way. And of course, you can flip it upside down. Which one you use? Well, that totally depends on which unit you're trying to get rid of.
And this is the golden rule, right here. You pick the conversion factor, the ratio, that cancels out the units you don't want and leaves you with the unit you do want. It's all about that cancellation.
Let's try one. A competition frisbee weighs 125 grams. We want to know what that is in ounces. So we take our 125 grams and we multiply it by our conversion factor. Now here's the key. We put grams on the bottom of the fraction. Why? So the grams on top and the grams on the bottom cancel each other out. See ya. All we're left with is ounces. Do the quick math and you get 4.41 ounces. Simple as that.
All right, this is where things get really cool. This is where dimensional analysis goes from being just a neat little trick to an absolute problem-solving machine. We're going to start chaining these factors together.
So let's take on a bigger challenge. Imagine a Lamborghini goes 1,250 kilometers and uses 213 liters of gas. I mean, what does that even mean to most of us? I want to know what that is in good old miles per gallon. And this looks kind of tricky, right? We've got to convert distance and volume.
But just watch. We can build one single chain to solve this whole thing. We start with what we know, kilometers per liter. First step, let's get rid of kilometers. We'll multiply by a factor with kilometers on the bottom so they cancel out, leaving us with miles on top. Bam! Kilometers are gone. Next, we need to deal with the liters. So we multiply by a factor that has liters on top, canceling the liters on the bottom, and leaving us with quarts. There go the liters. Last step, let's get from quarts to gallons. We multiply by a factor that cancels out quarts, and we're left with gallons. So look at what's left. The only units that survived are miles on top and gallons on the bottom. Exactly what we wanted.
You're on the numbers through a calculator. And what do you get? 13.8 miles per gallon. Not great, but now we know. We just took a pretty complicated problem and solved it in one single beautiful step just by chaining our factors. Okay, so this method it's pretty much magic. It works for almost everything. But there is one big exception we need to talk about. The one special case, converting temperature.
So what's the deal with temperature? Why is it the odd one out? Well, most units are what we call proportional. Think about it. 0 inches is 0 centimeters. 0 pounds is 0 grams. They share a true 0 point. But Celsius and Fahrenheit? Their 0 points are totally different. 0 degrees Celsius is when water freezes. 0 degrees Fahrenheit is, well, it's just really cold. Because of that different starting point, you can't just multiply by a simple factor. You have to add or subtract to adjust for that offset.
And because of that offset, we have to use actual formulas instead of our handy conversion factors. Here are the main ones you'll need. So if a recipe tells you to preheat the oven to 450 degrees Fahrenheit, you can just plug that number into the formula and see that it's about 232 Celsius. For temperature, it's really just about remembering to use the formula.
And that's really the whole system. You've got it. So let's do a super quick recap of how to use this new superpower of yours. So, here's the code, broken down. Number 1, always treat units just like numbers. Number 2, use conversion factors as your keys to change from one unit to another. 3, always set up your key to cancel the unit you don't want anymore. 4, chain those keys together to solve the big, messy problems. And finally, just remember that temperature is the one special kid in the class that needs its own formula. That's it. That's the entire secret code.
So there you have it. You now have the secret code. You have the tool to confidently solve pretty much any unit problem that life throws at you, whether it's in the kitchen, in the garage, or for a class. So the only question left is, what real-world puzzle are you going to solve first?